Assalamualaikum and a very good day to all. So we continue from our previous lecture on food spoilage and also microbial growth. So this is lecture 11.2. In the last lecture, we have learned that how nutrient contents can influence the microbial growth. Now we will continue on other factors such as pH, water activity, relative humidity, and so on. The next factor that influence the growth of a microbe is pH of the food. Naturally, most of our food such as meat, fish and vegetables, they are slightly acidic, while most fruits are moderately acidic. We have a few examples of foods that are alkaline, which is, for example, egg white. Now, microorganisms, they have optimum, minimum and maximum pH for them to grow in food. In the next slide, a list of microorganisms with their favorable pH for them to grow and also minimum and maximum pH is given. So bacteria, they grow fastest in pH 6 to 8, while yeast, they grow fastest at pH 4.5 to 6. In general, pathogens, they do not grow or grow very slowly at pH levels below 4.6. Of course, there are some exceptions. For example, fungi, filamentous fungi, they can grow at pH 3.5 to 4.0. Our food also can become less acidic during storage. For example, we have initially an acidic food and throughout the storage, the mold grow on them and this food become less acidic. When they become less acidic, the food then become favorable for growth of another microbe such as C. botulinum. When we want to use or manipulate pH to preserve our food, we can scientifically valid use pH as minimum of 4.2 to control or prevent the growth of salmonella and other vegetative pathogens, while 4.6 to control the spore-forming pathogens. And importantly, the pH. So here is the list of microorganisms with their minimum, optimum and maximum pH. So our attention is on Salmonella and also Yersinia enterocolitica, in which they are able to grow on acidic food as minimum as 4.2, the pH values. So if you know that your food are favorable or have the risk for Salmonella and Yersinia enterocolitica, so you may consider to reduce the pH of your food to 4.2 in order to prevent the growth of these pathogens. So here we have our common food with their pH values. We have limes, for example, at pH 2, okay, very acidic. And then we have fruits and berries at pH 3.5. We have veggies and melon at pH 5.5. And also we have meats and milk at pH 7. And we also have here pH 4.6 as our cut-off value, whereby we know that when food have pH less than 4.6, this means the food is very acidic and therefore they do not support the growth of microbe. Whereby when the food have pH more than 4.6, the food are considered as less acidic and therefore they are perishable because their pH support the growth of a harmful microorganism. So the next factor is the antimicrobial substance and biological structure. Okay. In natural state or in the raw state, plant and animal derived foods, they have biological structures that prevent the entry and growth of pathogens. Example of physical barriers, for example, skin of fruits and vegetables, okay, shell of nuts, okay, shell of eggs. So when you damage this biological structure, for example, due to handling during harvest or transport and storage, the damage can allow the insects and also the microorganism to penetrate and contaminate inside the food. And also during the preparation of food, process such as slicing, chopping and grinding, they can also destroy these physical barriers, and therefore the interior of the food can become contaminated and growth of microbe can occur, and therefore processed food in such state they are more perishable. For example, salmonella, they have been shown to grow on the interior of cantaloupe that has been cut. Okay, and egg, they have effective biological structure when they are intact or not broken. This structure is able to prevent microbe from contaminate the perishable yolk inside the egg. And in addition, the egg white also contains antimicrobial factors, which is called lysozyme. And for the interior of an egg to become contaminated by microorganism on the surface, this microbe must penetrate the shell and also the membranes. That's why when we purchase eggs, we want to check if they are broken or not, so that we do not consume contaminated eggs. So the last factor for this lecture is relative humidity. Relative humidity is the amount of moisture in our atmosphere or food environment, and this is called extrinsic factor because relative humidity is the factor that comes from outside food. Intrinsic factor are factors that comes within the food itself. For example, pH of food, nutrient contents of the food, they are called intrinsic factor because they comes within the food itself. Now, if we have dry food that are placed at high humidity environment, this dry food can take up water and become moist and therefore get spoiled easily. For example, we have dry grains that are placed in an environment with high humidity. They can take up water and therefore support the growth of mold. Here, packaging plays a major role in protecting the food from the effect of relative humidity. However, even within a sealed container, the moisture still can migrate inside the container and affect the food. And also we have the phenomenon of temperature fluctuation in our environment that can also damage the food, because it has been observed that certain dry foods, they can be subjected to moisture condensing on the surface because of the environmental temperature shift, and this surface water will result in micro environment that can support the growth of pathogens. So as a general guideline, the product must be stored or must be held in the environment as such that the moisture will not have an opportunity to alter the water activity of the food in a way that can support the microbe growth. So with that, I end my lecture 11.2, and please log on to PutraBLast and answer a short quiz. Thank you.